ABS medical, biocompatible up to 30 days in contact with the human body. And yes, according to the manufacturer, it's even approved for the food contact. Hello, welcome to my tech farm. Another special filament on the test. This is ABS Medical by Spectrum. I bought this filament myself from the budget which I got from the polymaker who is supporting my research activity, and I have a budget to buy any filament I want to test. About this filament, according to the website, biocompatible up to 30 days in contact with human body. Of course, this is only external skin contact, so no adult toys. Food contact approved by EU and FDA. This is surprising because ABS contains styrene, and because of this I thought it cannot be used in food contact applications, but they got the certificate, so yes, of course. The other question is the contamination, because those gaps between the layers are a great place for the bacteria. Now, wicked softening temperature is 95 degrees Celsius. And what I also want to try in this video, to see if it will survive short boiling temperature. Or maybe I will just turn off the heat and then place it, I don't know, 5 minutes or something like that. And I want to see if, for example, the layer adhesion will be much weaker after this cleaning method. Examples for the application: lightweight prosthesis and medical support structures. Just a few more thoughts about these food contact applications. I was talking about it earlier that even if we don't have nice cleaning method, we can use it only short time. Typical examples are cookie cutters. We use them and then after the season we can throw them away. But in this case I prefer using some PLA without any coloring pigments instead of the ABS, because it is a smaller impact to the environment when we throw them away. So I hope this cleaning method will work, and in this case this ABS can be reused, I don't know, next year or something like that. Very good vacuum packaging, and we have some print information on the sticker. Temperature between 240 and 270 degrees Celsius, and on the bed between 80 and 100. So this is typical for the ABS filaments. Looks like the bag is resealable on the shorter side. Wow, it is very full, because the density of the ABS is quite small, and to have 1 kilogram on the spool, it is very full. Probably this is not brittle filament. Yeah, I can completely bend it. But see, this will be a problem. It may fall down from the spool because it's very full. I cannot even reuse these holes for the locking end of the filament. That's why many companies place 0.9 kilograms, for example, on these standard spools. I have to be very careful during the printing to supervise it if it will not fall down, at least at the beginning. Wow, it is so full that it cannot go into the AMS unit. Okay, then external spool holder. Wow, before my test objects, I just really want to print something bigger so I don't have this problem with the full spool. It continuously falling off. I move it down. I have these DIY holders. It is a much safer solution in this case. The filament is loaded, and even now I can feel that smell of the ABS. I will use textured PI sheet without any glue. With 100 degrees Celsius it should be okay. Slicer settings: generic ABS, the start profile, 60 chamber temperature, 100 on the bed, 270 the print temperature, and 15 will be the maximal flow, and cooling I reduce between 0 and 50%. And these are my typical test objects, but for the layer adhesion I am removing because it will be tested separately. The printing is completely fine so far, but when I came to the room to check the printing, I could feel that unpleasant smell of the ABS. Bed started to cool down. Let's see the adhesion. Perfect. And I opened the window to ventilate the room. For the layer adhesion test, I will have more test objects because I want to test that cleanability and if the layer adhesion will be changed. And good news, this spool holder works great, even with this full filament. I need something for the thumbnail image. A finger splint from printables. Do you know if you reduce the layer height, this is printed with 0.16, the printing time will be longer, but the overhangs will come out nicer. Less need for supports. Really comfortable, scaled up to 125%. A funnel tray, also from printables. And soon I will be able to lock end of the filament inside those holes. And when the bed cools down. And a regular funnel, and I'm curious how will those overhangs look like, 45 degrees, but from here so far looks okay. Nice. Few cups for the cleaning test with the hot water. But first let's start with mechanical testing. For the comparison, I will use the values for the average ABS without any fiber reinforcement, and in that pattern summary table I have 16 items. 3-point bending test, distance between supports is 50 mm, and I'm placing these loads and I'm measuring the deformation after 1, 30 and 60 seconds. And currently you can see the deformation under 10 kilograms. And after this test, visually I can see some deformation. It's not too big, but it is noticeable. Similar mechanical properties, just a little bit smaller deformation of the ABS medical compared to the average ABS, but even that additional deformation during the 1 minute is very similar. For example, here under 10 kilograms it is very noticeable. This is my new bending test. Follows better the ISO 178 standard. This is the real-time speed. Distance between supports is 64 mm, and supports are rounded, 10 mm diameter. And this part is speeded up 4 times. And there was no break in this case. And here you can see the graph and the maximal load. And here you can see even the bending strength and elastic modulus. This testing I started recently on my new universal testing machine, so I don't have enough data. I will include here for the comparison the ABS Keller from my previous video, and in both cases this ABS Medical have a small advantage, a little bit bigger bending strength and elastic modulus. And soon I'm preparing the video which I will explain these two values, because you will see them a lot in my future videos. Impact test, I'm starting with ISO. The object is located in vertical position, and results from 3 measurings. Sharpie, horizontal, supported from 2 sides, and results from 3 measurings. For the Sharpie I don't have enough data, but for the ISO I have a lot of materials for the comparison. Now, average ABS, but in this number some ABS PC blends are also included, and if I exclude them, then we have this number. It's still bigger compared to this ABS Medical, so it is more brittle compared to the average ABS, but still far tougher compared to any PLA or PTG material. Test size strength, horizontally printed objects. This value is noticeably weaker compared to the average ABS tensile strength. Now I want to see how it handles these almost boiling temperatures. I stop the heat, and the temperature falls down to 93 degrees Celsius. I insert the test objects in the water. I make sure they are completely sink down. And after 2 minutes the temperature falls down to 84 degrees Celsius, and the objects are still perfectly hard. Even for the touch, everything is fine with these objects. Even the test objects are in perfect shape. Again I boiled the water, but this time immediately when I turned off, I placed some objects in the water. And again they are still completely hard. I boil the water again. When I turn off, I try to place these objects a little bit longer in the water, but still everything is okay. Objects are marked, and now we have another cleaning method in dishwashing machine, 70 degrees Celsius, And I have this net, so I can place these small test objects into machine. They are still in one piece. After the washing, visually there is no any degradation or deformation on the objects. But let's measure the layer adhesion. Reference without any cleaning. Cleaned in almost boiling water. Longer cleaning in dishwashing machine. This is my rating for this test object, and in all three cases we can see that this ABS Medical have a good layer adhesion compared to the average ABS. About the cleaning methods, this was that short boiling method, very minimal difference, and here it was exposed to this 70 degrees Celsius almost 90 minutes, which is quite long. And what we can notice here is some bigger jumps, standard deviation between the number, so we can see even some bigger numbers. Maybe the objects are exposed differently to this cleaning 70 degrees Celsius water, but anyway, this is still a good layer adhesion. Question is, if you repeat this a few hundred times maybe, how will it reduce? But looks like this very short boiling method is a good cleaning method. Shear test, horizontal and vertical. Printed in horizontal position, very similar value compared to average ABS. Printed in vertical position, the layer adhesion is important, and here we can see big improvement compared to the average ABS material. Torsion test, horizontally printed. Loaded 90 degree rotation. 1.4. At the maximal load. Printed in vertical position. Break suddenly. 1.4. As always, similar numbers, but different break types. Printed in horizontal position, loaded 90 degree rotation, small advantage on the side of the ABS Medical, and printed in vertical position, the maximal load is bigger again with the ABS Medical because of that better layer adhesion compared to the average ABS. Creep test, the deformation under constant load of 1.25 kilograms, 1632. So this is the initial deformation, and now let's jump 5 days. Day 5, the last measuring. 17.05. Let's remove the load. On this graph we can see the distance between two reference surfaces, and we can see that this deformation is very similar to the average ABS. Creeping is the difference between 2 days, and we can see some small difference here on the first day, but after this the creeping is extremely similar. Temperature test in the oven, and this is the filament from this video. I want to record the temperature of the first noticeable deformation. For the average ABS, this is 94.3 degrees Celsius, and this was quite close to 92 degrees Celsius. And when I stopped the experiment, after 30 seconds, it was quite hard already. Our results one more time. Creep test, tensile test and the layer adhesion with some cleaning methods. Shear test, horizontal and vertical. Bending test, the deformation after 30 seconds. Bending test, deformation under these loads after 130 and 60 seconds. Torsion test, horizontal and vertical. Impact test, ISO and Sharpie. Temperature test. And that new bending test. I actually like this filament. I'm wearing this just for the testing 1 hour now, and it is quite comfortable. You know, compared to the plaster, I'm not sure what is the official name. This is much more comfortable, you know, with these holes, you can scratch it. And being a food safe filament, this is new to me, ABS, food safe, but cleanability on this near boiling temperature, this is great opportunity. Of course, I wouldn't use it for the egg separator, you know, yellow, white, but from some other applications, why not? And actually, I really like this stronger layer adhesion. Tensile strength is quite weak, but the layer adhesion is good. Actually, I printed these clips for locking end of the filament because here it needs a stronger layer adhesion. And I like to use this from the ABS not PLA or PETG, because sometimes I forget which is the material, and if I want to dry that filament, in that case I have to be careful which material I use for the clip. And using ABS, I know that I can dry that filament up to, I don't know, 85 degrees Celsius in nowadays those new filament dryers. So what is your opinion? Do you have some application for this kind of material? Write your thoughts down in the comment section. Huge thanks to the Polymaker for sponsoring my channel, and huge thanks to all my Patreon supporters, and together they make these kind of videos possible. And to all you others, thank you for watching this video to the end, and happy printing!